Hello and welcome to the next lecture on operating system. In today's lecture, we will learn about main memory concepts. So, to avoid the corresponding program's misbehavior during the memory accesses, the base and limit registers are specified in the memory management unit. So, a pair of base and limit registers defines the logical address space. The CPU must check every memory access generated in user mode to be sure it is between base and limit for that user. So, for example, if a process is allocated the corresponding memory range, the user process should use that memory range. Otherwise, the error will occur. So, it is not using the memory properly. So, it is using or it is about to use some other address space which is not it's intended to do. So, that's why a pair of registers in which the base address and the limit address is specified during the program execution. Whenever the corresponding request for getting any data or instructions from the memory is generated by the user process, the corresponding limit of the addresses is checked by the operating system. So this is the schematic view of how the hardware address protection is implemented. So the CPU generates the address. Okay, so this address should be valid such that it should be greater than or equal to the base value, base register value. If it is yes, then if the range, if it is between base plus limits. So if it is less than that value, then the corresponding reference goes to the memory. Otherwise, in both cases, the corresponding trap to the operating system is generated because it is the invalid address that is requested by the user process. Generally, the physical address, the corresponding address generated by the CPU is converted into physical address, right? Mapped onto the physical address. This scenario we call it as address binding. So the programs usually reside in disk. It is ready to be brought into memory to execute from an input queue. So without the corresponding address supported, like this address binding is supported, so the corresponding every program should be loaded into the address 0000. Okay, that is the starting address of the memory. But it is always inconvenient for the user process because always the corresponding programs, whenever the program needs to be executed, it should be loaded into the 000. So to overcome this difficulty, then the corresponding concept of address binding comes into picture. So the next issue is that further the addresses were represented in different ways at different stages of a program cycle. Okay, so it is not a sequential addresses the corresponding program resides. So the program instructions and data resides in different addresses. So that is not always possible that every program should load it into the 000 location. So the source addresses are usually symbolic in nature, and the compiled core addresses bind to the relocatable addresses. So this is that what happens in the address binding. So that is put in bytes from beginning to the corresponding module. So the linker or loader will bind relocatable addresses to absolute addresses. So each binding maps one address to space to another. So usually this address binding of instructions and data to memory addresses can happen at three stages. One is called as compile time, another one is called as load time, and during execution time. So if it is take place in the during the compile time, that is the memory location known a priori. Okay, so which particular memory location our program is going to reside. So we call it as an absolute code can be generated in this case. So if it is not the case, then we need to must recompile the code if starting location changes. So if a particular program runs for the first time and this is the starting address and this is the ending address, we know that priorly. So the corresponding that is binding can take place during the compile time itself. But this is for the first it is. If the program again re-executed for certain stages, certain time, after certain time. Okay, but that time if you do not, if it is not going to be occupy the same memory range, then again the program needs to be recompiled because we have already hard coded that this is the address where the corresponding program is going to locate at the physical memory. So if that is not the case for the second time, then the recompilation should be done. Well, if the load time, then must it should generate the relocatable code. Okay, so if memory location is not known at the compile time. So, and the third case is execution time binding. It is the binding is delayed until the runtime. The process can be moved during its execution from one memory segment to the another. So usually, practically, the third is the corresponding binding that is used in most cases during the execution time. So this is the pictorial representation of the multi-step processing of a user program. The source program is compiled, okay, and then the object module is generated while the linkage editor links the other object modules, and the load module is going to load the corresponding program and the system libraries. Okay, so that this is going to be the responsibility of the loader and in memory. So once that is loaded into the physical memory, then this happens during the execution time, where the dynamic loaded system library is also linked using the concept of dynamic linking. So this is what happens during the multi-step processing of a user program. So what is this logical versus physical address space? The concept of a logical address space that is bound to a separate physical address space is central to proper memory management. This is very important. The logical address are generated by the CPU and it is also called as virtual addresses. Why we call it as virtual address means this addresses range is not known to the computer. That is your CPU. Physical address addressing by the memory unit. The logical and physical addresses are the same in compile time and load time address binding schemes. Okay, so the logical, virtual, and physical addresses differ in execution time address binding scheme. Logical address space is the set of all logical addresses generated by a program. Physical address space is the set of all physical addresses generated by the program. So, for entirely managing these concepts, we have a memory management unit. So, it is hardware device that at runtime maps virtual and physical address. Many methods possible in this memory management unit, like paging, segmentation, paging with segmentation, etc. So that we are going to learn in detail in this unit further. To start, consider a simple scheme where the value in the relocation register is added to every address generated by user process at the time it is sent to the memory. So the base address now called the relocation register. Usually the MS-DOS on Intel 8086 used four relocation registers to handle this memory management. The user program deals with the logical addresses. It never sees the real physical addresses. So execution time binding occurs when reference is made to location in memory. Logic address bound to physical addresses. So if you see here dynamic relocation using a relocation register, the routine is not loaded until it is called. Okay, so whenever the routine is called, then only it will be loaded into the memory. Because to avoid the utilization, that is unnecessary utilization of the memory. So better memory utilization will be implemented in this case. Okay, so the unused routine is never loaded. All routines kept on disk in a relocatable load format already it is kept on that format, so that whenever it is called, it will be loaded into the memory. Useful when large amounts of code are needed to handle infrequently occurring cases. So no special support from the operating system is required because it is already handled by the hardware. So the CPU generates the logical address. The relocation registers available in the memory unit management unit adds the corresponding offset to the logical address to generate the physical address. So this is how the dynamic relocation takes place. In the next class, we will continue the further topics in detail. Thank you.